Hello everyone, welcome back to the SVAN Talks. We got an awesome session linked up today. If you are watching this live, make sure to like, share, and subscribe to our channel, and also do the bell activation function. Oh, no, 1 minute. Yeah, if you are watching, sorry for the interruption. If you are watching this live, make sure to like, share, and subscribe, and also hit the bell icon for the upcoming videos. Okay, coming to the today's session, we got an awesome speaker. We are honored to have Mr. Vishwanatha Perala with us. He is a lead machine learning engineer who specializes in building scalable machine learning systems with experience work in the UK and contributing to the high impact projects in industry. So without talking much time, let's welcome our speaker, Mr. Vishwanatha. The stage is yours. We can get your insights. For
Awesome. Thanks, Aegis. Thanks for the invitation. So before I get started, now I hope my voice is clear. And
yes, sir.
perfect, perfect. Um, I'll keep my introduction short, and I'll try and get started with the session. This session, okay. So hi everyone. I'm a machine learning engineer by profession and a avid basketball lover on the side. So my career, uh, like all of the previous guests that you've got, my career hasn't started uh, like this. I'm into basketball a lot, so I joined in my college as well, knowing that there's a basketball court. That is all that I needed. So for the first 3 years, I was always on the basketball court trying to play, make the best of the time. My goal was simple. I wanted to take my team for the state basketball championship. Long story short, we didn't, and that is why I've become a machine learning engineer. So till third year, I've never really coded. I was not really interested in studies or anything. And then I was on basketball court for the most part. And third year, when we lost the tournament, I thought, okay, I need to get away from this thing, and I ended up in a hackathon. I participated. I went there all by myself, met people, formed a team, developed an application, presented an application, got selected. Our idea got selected for the global level hackathon. This was back in 2017, and fortunately or unfortunately, fortunately only there was a there was a team competing against us, which is a software company. They looked at what we did and they offered me an internship, and that is where I met the infamous Srikanth. So I met him there. Then that is where I got introduced to machine learning, and that is how I got into machine learning. So that is my quick introduction, and yeah, uh, for me, machine learning is all about solving problems. That is how I look at machine learning, and this session today is kind of taking inspiration from there. How I learned machine learning, or how I look at machine learning in the general sense. So hopefully, in the next 20-ish minutes, I'll not take much of your time, but in the next 20-ish minutes, I'll try to talk to you about how I look at machine learning. Disclaimer: this is not a math session. This is not a machine learning session. So if those are your expectations, I'm sorry. Uh, it is not that. Okay. So with that being said, if let me know if you're able to see my screen. Uh, Center screen. Okay, sure. You're able to see my. Hopefully, you're able to see my screen.
yes, we are.
Okay. Uh, let- You're able to see my screen, kada? Okay, perfect. Awesome. Um, so first things first, I want okay. So background effect గురించే దాని గురించి ఇంకేం లేదు. So I titled this session as Math, Machine and Madness. So if at all, as a statutory information, if you have any questions, if I'm going too fast, if I'm not clear or audible, uh, one of you please let me know, and I'll try and you know correct whatever it is. Right. Um, all right. Now with that out of the way, why did this session start? In the first session, I think Satvik Reddy, one of your classmate, he's asked a question. Okay, he's asked the question is, uh, should I learn the SEM subjects or improve on skills? Luckily, I mean, the speaker then really answered it well, and that has driven or inspired me to take this session in this route, where I talk about the fundamental concepts that we've learned in intermediate or engineering first year or somewhere down the line in your engineering, and how those concepts that you study outside of your traditional machine learning classes, how those things are the fundamental blocks, so to say, in the space of machine learning. So and how these ideas are simple, which are like hidden. So before I go further, please take your mobile phones and scan this QR code. uh, so I'll be starting a questionnaire kind of a thing. So it comes in between here and there, so you will have to be answering. Don't worry, మీరు I'm not నేను దీంట్లో నుంచి ఉన్న క్వశ్చన్స్ అడగను. So it will be a generic general questions. So అందువల్ల it's good if you pay full attention to what I'm saying. Uh, so okay, see, people have started joining. Okay. Okay. I'll give a couple minutes for all of them to join, and then we'll get started. All right, 30 seconds. I'll start the thing. All right. So I'm going to start the questionnaire. Um, hopefully, I'll put the code in the chat as well. So if someone wants to join, uh, Karthike, if someone needs and if you need to share, so you can use this link and the code for them to kind of join. Okay, this and this. Okay, you can share this in the group and
Okay, bro.
all right. Um, okay, so start now. Okay. Uh, okay. Can you please answer the first question, and in the meantime, I'll try to figure out how to cut down the sound settings. Oh God. Okay. Okay. Cut. Uh, okay. Fine. Mhm. How do I fix the sound? Uh, Fine. I don't know how to cut down the sound. Hope it's not too loud. All right. Um. Okay. Um. Oh. So seems like majority of you are from AML stream, so that helps me um, so much. So okay, now that that is out of the way, let me let me go on with the next question. You should see another question now. Okay. Um. Okay. Okay. All right. Um. Interesting. I don't know what I've given us the right answer, but anyways, um, good. Uh, Now another quick question, and after that we start. Okay. Now. Okay. And that's all right. Uh, okay. So I've not given you much of the chance to essentially say if it is a good thing or bad. For those who didn't know what the question was, I asked them if it is a good thing that Satvik has asked the question in the first session, which led to this talk. Um, all right. So now, as I told, so this is an attempt to talk about the mathematical perspective of machine learning. So first, since you majority of you are from AIML stream, it this is going to be a no-brainer for you. This is just a high-level overview of what what happens in a traditional let's say in this scenario, in this case, what I'm trying to show is a traditional classification problem. So classification problem is any problem which is classifying between two things or multiple things. So this is a high level where you have an input, then that is understood by uh, like a computer in a numerical way. So it's got a lot of numpy arrays that is essentially packing up the RGB information of the image, and then you are training it with a, like, let's say a fully connected neural network. There's something happening there where it is learning the differences between a cat and any other animal. So at each layer, you've got weights that are getting updated. Again, don't think much about these, but I mean these keywords, but general Heisen's weights are basically what influences what. So we've got a model that is learning essentially what features talk about cat, and then once that is there, then you have the final prediction whether something is a cat or not. That is how a traditional machine learning algorithm operates, right? You've got a decision bound tries to figure out for a classification problem. So now this is the stage where, like, essentially figuring out what would be that boundary or decision plane be, and then it basically separates. Okay, if any point lies in this side of the hemisphere is like cat, and in anything that lies in this side is not a cat. Simple classification problem. So this is how a general model that you build, this is what goes into it. But now these are all the things that you can get out of the shelf, right? You can use sklearn to bring up, load models, train the model. You just do trainer.fit and it starts working. But what I wanted to go is go back and talk about what happens here in this place, where what is happening here, and what are these, why do we need that, and what are the things that we can do with those, and also what are these, and eventually understand what this decision boundary is all about, and how it actually operates in a real world scenario. So that is what I'm trying, my attempt is in this session. And right now, uh, quick question for you guys again. So all right, I've just started the next questionnaire. Just look at the question and try to answer. This is something that we've learned. Again, me gurtunna machpena, it is okay. It is just for me to understand what is your understanding of a vector, whatever you remember of a vector. Oh God. Okay. Magnitude and direction. All right. Right. So that is true. Uh, Vectors are something that encode direction, magnitude. I will just extend this in a way where it also encodes meaning. Again, not in the literal way, but there's a caveat to how I understand, how I try to bring this into the whole definition. So here, what I mean by adding meaning is the information or the features that it talks about. Right? It brings in its own knowledge, its own understanding into models, such that model is able to learn learn information, learn patterns. So at the end of the day, machine learning is trying to solve a problem, be it anything. What it is trying to do is learn from the data, learn patterns, learn information. Um, Again, in the case of chat GPT or any kind of LLMs, it's basically creating its own dictionary, its own language, so to say. So all of this is made possible because of vectors. And this is something that we've done probably in our first year, where you'll talk about vectors, vector spaces, eigenvectors, eigenvalues. So how many of you remember, if you remember, just quick raise of hands in this, in the meeting, how many of you remember those vectors and vector subspaces, vector spaces, eigenvalues or eigenvectors? Quick show of hands, right? Okay. So then I'll try to briefly introduce what vectors are all about and how vectors really shape uh, your your traditional machine learning spaces, right? For okay, now quick show of hands again. How many of you have worked on agents? No one has worked on agents. Anyone has worked in any NLP projects? Let's say sentiment analysis or uh, ham spam classifier or mm, what else? Let's say a general classification problem. You've worked on it, right? So in all of those things, the data that you have, right, all of the data points, the data set that you've got is in a way a vector. Okay, so how is it a vector? How is it packed as a vector? So one is, it is a, so there are two ways in which you can see. One is the multidimensional space, or so multidimensional points, right? Your data set is this big grid of data, right? So let's say you're looking at a basketball. Okay, again, I am biased to basketball, so bear with me if I'm giving you a lot of examples with basketball in mind. But let's say if you want to classify someone as a basketball player or not, you have your own దాన్ని ఏమంటాం, bias, దాన్ని ఏమంటారు, your judgment, right? పొడుగున్న వాళ్ళు బాస్కెట్బాల్ ఆడతారు, పొట్టిగా ఉన్న వాళ్ళు బాస్కెట్బాల్ ఆడరు. లెట్స్ సే దట్ ఈస్ వన్ ఆఫ్ ద జడ్జ్మెంట్ అనుకుందాం, ఆర్ స్టీరియో టైప్ అనుకుందాం. సో అలాగా, సో నౌ యువర్ డెసిషన్ ఇస్ బేస్డ్ ఆన్ హైట్. Now height is one such axis where you are able to make a decision. So these vectors essentially make that possible for you, right? So all of the different uh, features that you've got in your data set, all of the different columns can be represented as axis, and each axis has its own representation with the help of vectors. Now that is one thing. The other thing is the features, image space law. Vectors make it possible to kind of capture different features of information. For example, in the case of cat, దాంట్లో తీసుకుంటే one feature talks about the fur length, one feature talks about the colors, the color range of a cat, ఏమేమి ఉండొచ్చు, or let's say eye shape ఎలా ఉంటుంది. All of those features are captured in one. So vectors make those small things that you don't usually see in a machine learning model training. Where just nowadays that you just load the data set, you pick a model, you say okay, fit, and you fit the thing and it does something, and you then use it at inference. What you're going to look at is okay, now when I do it, it's learning each epoch I see a loss. So what my goal is to get this loss to as low as possible. So for the model to get to that point, vectors are the fundamental things. And if you understand this layer, it'll also help you in understanding, let's say, embedding strategies aవచ్చు. Uh, uh, so vectors in that way play a very crucial role to pack information. So for example, ఇక్కడ ఏదైతే చూస్తున్నారో, let's say these are the information about uh, let's say Tejas, right? Tejas is a basketball player, and let's say again, let's say 2 meters is the height. His height is 2 meters, and he's let's say 100 kgs weight, and he plays in shooting guard position, right? So all of that information is captured in this particular vector, and this is then used for model at inference also. Inference ante when you run the model and get the predictions or whatever, right? So that is the inference engine. So that is to do with the vectors, right? So um, now everything is good. Okay, this is able to give us it is able to pack information, it is able to give a lot of this different spaces and all, but why do I even need it, right? So daniki, it's a quick video where this talks about how these enable us to encode meaning or understanding. Now this is the input, right? All data in deep learning must be represented as vectors. Now each word has its own representation in the high dimensional space. High dimensional space is it's a చెప్తున్నాను కదా LLM లో it creates its own grammar and all. So these vectors make it possible so that the information, the data that is coming in can be represented uh, in this అంటే మనం ఇమాజిన్ చేసుకోలేని హై డైమెన్షనల్ స్పేస్. So once this gets done, what we are trying to do is okay. Now I'll try to get the meaning that is encoded in this. Now this is a really good example. Now I've got okay. Now the relation between man and a woman is like this. Okay, but would the same relation be for uncle and aunt? Yes or no?
Yes,
What makes you say that?
like both male and female, rather than name.
Correct. Okay. Now ఇంకో ఎగ్జాంపుల్ వస్తుంది. Okay. Now okay. Okay. Now tell me something. Germany's got Hitler. Italyకి ఎవరున్నారు? మీకు I'm not sure if you are aware of this.
It might be Missouri or something. Am I right?
Correct. Mussolini. Yes. So again, now you are able to make those connections because you kind of identify a pattern. Okay, Germanyకి there was this ruler Hitler. So అలాగా ఇటలీకి ఎవరున్నారు? Now you have that knowledge because you've got your own learning that you've done. Similarly, how would a general LLM know about this? So all of this is possible because of these fundamental math concepts called vectors. I think. Oh, sorry. So now, okay, this is what I wanted to show, which is there is these vectors help us get the capabilities of a relationship between words, uh, between phrases or words or whatever. It helps us enable that. Now, uh, okay, so far we've okay, the vector question. Okay. Hmm. Replay question in the okay. Okay, what? Okay, అంతే కదా. All right. So now that this is out of the way, vectors, which is the fundamental at starting stage. Now let us answer another quick question. Okay, I'm starting the next question. Okay. I think అక్కడ క్వశ్చన్ లో చిన్న కరెక్షన్, హౌ కాదు హూ. హూ డూ యూ థింక్ is a basketball player out of those people? Again, there is no right and wrong. So, all right. So, again, if you look at it in your head, the decision the decision is like, okay, 6 feet kana ekku ఉన్న వాళ్ళు, let me consider as basketball. Like 5'3" player can also be a basketball player. Anyone can be a basketball player. But in our heads, when we try to make a decision, make a classification, whatever, we try to use our own understanding as the decision, right? So alage, if you see, you've drawn that, let's say few of you drew the line at 6 feet, few of you didn't draw any line, you made it like anyone can play basketball. So all of this is somewhere close to what we do in a simple linear regression. So where we are drawing a line that is essentially defining, okay, this is what I've learned from the pattern, from the data that I've got. This is how the boundary would look like. Now, in order to do that, so okay, మీలో ఎంతమందికి స్ట్రైట్ లైన్ ఈక్వేషన్ గుర్తుంది? Ravi, can you give me the equation? Or Jyoti? Should I? నేను జనరల్ ఈక్వేషన్ అడుగుతున్నాను రవి.
Y is equal to mx plus c, sir.
Correct. Y is equal to mx plus c, right? So y is equal to mx plus c gives you a straight line where you've got m as slope and c as intercept. And what you're essentially doing is, okay, this defines where exactly the line is going through and what are the different points that fall on this line. Now, if we take the same concept in terms of machine learning, on a linear regression, if I take that example here, the y is equal to mx plus c becomes y is equal to wx plus b. I'll give the notations as to what w and b are, but do you know what w and b stand for, if anyone knows?
Weights and bias.
Right. Now, the same concept of straight line, no, when you increase it, a straight line becomes a plane and in three-dimensional. So all of it's the same thing, same fundamental concept that we've learned. It carries through to machine learning as well. Similar, I'm not saying literally. So now, with regards to weight and parameter, I want to introduce this here so that going forward అంటే ఈ definitions are clearer. So weights are essentially the influence. Okay, each axis తాలూకు influence ఏమిటి ఒక particular data point మీద. Let's say, if again going back to the same example of a basketball player, height is one such criteria which influences a lot of your decision. Now, నీకు the reason you are able to give more emphasis or more weightage, okay, better example, మీరు సబ్జెక్ట్స్ చదువుతున్నప్పుడు యూ ఆస్క్ యువర్ ఫ్యాకల్టీ కదా, ఏ ఏ చాప్టర్కి ఎక్కువ వెయిటేజ్ ఉంది ఆర్ విచ్ క్వశ్చన్స్కి వెయిటేజ్ ఎక్కువ ఉంటుంది. అలా అడిగినప్పుడు దే గివ్ యూ, ఓకే, దీస్ ఆర్ ద కాన్సెప్ట్ దట్ యూ నీడ్ టు ఫోకస్ మోర్ and these are the concepts you can leave. So all of this is basically, it influences your learning, right? Okay, ఈ కాన్సెప్ట్ ఎక్కువ వెయిటేజ్ ఇమ్మన్నారు, సో ఐ రీడ్ ఆర్ ప్రాక్టీస్ మోర్ these questions than the other set of questions. Similarly, machine learning lo kuda the weights influence a particular learning. సో హైట్ తాలూకు ఇన్ఫ్లుయెన్స్ ఎలా ఉంటుంది, వెయిట్ తాలూకు ఇన్ఫ్లుయెన్స్ ఎలా ఉంటుంది, స్పీడ్ తాలూకు ఇన్ఫ్లుయెన్స్ ఎలా ఉంటుంది, స్టామినా తాలూకు ఇన్ఫ్లుయెన్స్ ఎలా ఉంటుంది. All of these different categories, what is its influence on the prediction, on the final value. So ఇది ఏదైతే ఉందో, దిస్ అండర్స్టాండింగ్ ఆఫ్ దిస్ ప్యాటర్న్ ఏదైతే ఉందో, దట్ ఈస్ అండర్స్టూడ్ బై మెషరింగ్ త్రూ వెయిట్స్. నా బయస్ ఇస్ లైక్ దట్, ఎలా అంటే ఇప్పుడు slight little nudge that helps in getting the prediction as close to the true value as possible. Now bias తాలూకు the ఏంటి అనేది I'll talk to you little once we reach something called as best fit. Okay, best fit line. So this way of learning through parameters influence over the data point that you've got. ఈ learning అంతా ఏదైతే ఉందో, this is what you look when you have those fully connected neural network. What is happening? Okay, what is the influence of a particular parameter is there on the weight, and it gets updated. And ఇక్కడ ఏదైతే ఉందో, it just goes back to this one, where you're essentially drawing this separation, right? ఇది ఏదైతే ఉందో, this is the best fit that was possible, such that the classification is clear or classification is accurate. Now where does this pass ikkada అని చూసుకుంటే, now it looks like it is passing through the origin, right? In some cases it will be somewhere along here, or somewhere up the axis, somewhere at a different angle. So all of this is achieved through weight and the bias that you are able to learn from the data that you've given, right? Now here what I'm trying to do is go from top down. Now we've looked at what is the overall how does the overall machine learning model operate. Now when I go top down, now we are looking at the small unit components that make up this model, right? Now first we've touched upon the vectors, which is the representation part. Now we've talked about the neural network. So neural network law, one such component is the learning, right? The decision boundary. For example, in our case, the linear regression, where we are able to learn that best fit that is possible. But in order to get to that best fit, ఏవైతే వెయిట్స్ అంటున్నామో, ప్యాటర్న్స్ లెర్న్ చేసుకోవడం, వాట్ ఎవర్ ద ప్యాటర్న్స్ దట్ ద మోడల్ ఇస్ లెర్నింగ్, all of these concepts are made possible because of one component. I don't know if it is okay to open this up as a question, but if someone knows the answer, I'm happy to listen to your answer. So what do you think enables machine learning models to learn from vectors to the final best fit line? Anyone? దీనికి నేను కొంచెం డ్రమాటిక్గా సౌండ్ యాడ్ చేద్దాం అనుకున్నా, బట్ అవలా. బట్ ఇట్ ఇస్ దిస్ మెట్రిక్స్ మల్టిప్లికేషన్స్. సో మీరు మీకు M1, M2, M3 సబ్జెక్ట్స్ ఉన్నాయా ఫస్ట్ ఇయర్లో? యా. సో M1, M2, M1లోనే అనుకుంటా, M2లోనా, యూ హ్యావ్ matrices, రైట్? యూ కైండ్ ఆఫ్ డూ ద మల్టిప్లికేషన్స్ పెద్దవన్నీ తీసుకొని. So
Yes, sir.
those small those matrix multiplication, M1, is what is behind all of the learning. So now, but how does that affect? And I'm sure మీరు matrix multiplication గురించి ఆలోచించి కూడా ఉన్నారు last 1-2 years లో. After the M1 subject, I don't think you would have ever thought about going back to matrix multiplications. Has anyone done anything in matrix multiplication over the last 2 years? I mean, assuming that all of you are in second and third years, first is తక్కువ మంది ఉంటారని అనుకుంటూ. No, right? So, but why do you think a matrix multiplication is needed? Of course, the answer is out, but basic transformations, geometric transformations ఏవైతే ఉన్నాయో, it enables those things. Now, what is a geometric transformation? అసలు ఫొటోస్ ఎడిట్ చేస్తుంటారు కదా, right? You flip the photo, you turn the photo, all of these things are possible, right? Why are those things possible? Basic I mean, ఈ దాని సబ్ టాపికే మన ఆన్సర్, రైట్? మేట్రిక్స్ మల్టిప్లికేషన్స్ ఏవైతే, సో these geometric transformations, మీరు when you're rotating an image, it is rotating at an angle, right? So ఈ angle rotation ఏదైతే ఉందో, this is what we call as geometric transformation, and this is possible because of matrix multiplications. So you're essentially doing something called as transposing a pixel from its original location to this new resulting location at an angle. సో ఆల్ ఆఫ్ దీస్, సో నా మనకి నార్మల్గా ఏముంది, ఇలా తిప్పుతాము, అది ఇమేజ్ తిరిగిపోతుంది, ఫ్లిప్ అయిపోతుంది, బట్ ది అండర్లైయింగ్ థింగ్ ఇస్ దీస్ జామెట్రిక్ ట్రాన్స్ఫర్మేషన్స్. నా ఫర్ ఎగ్జాంపుల్ వెన్ యూ, ఐ quickly show, okay, now there is this cat. Okay, now if I want to look at the outline of the cat, I want to see its edges, what do you think I need to do? ఇప్పుడు మనం జనరల్గా if you have to do, what do we do? మ్యూట్లో
క్వశ్చన్ ఒకసారి చెప్తారా?
So now you have this cat. If I want to get the edges of the cat, what do I do? Draw an outline. ఏదమ్మా?
మార్క్ చేసుకుంటాం, మార్కర్ లైక్.
కరెక్ట్. సో ఫస్ట్ మనం అవుట్లైన్ గీసుకుంటాం. ఇఫ్ యూ వాంట్ టు గెట్, మనం డ్రాయింగ్ బుక్స్లో యూ గాట్ దిస్ థింగ్, రైట్? కళ్ళకి ఒక అవుట్లైన్. సో ఇప్పుడు నేను ఆ లెవెల్లో కావాలి అనుకో, వాట్ డు ఐ డూ? అగైన్ వీ ట్రై టు ట్రేస్, అది మనం. బట్ హౌ డస్ కంప్యూటర్ know what are the edges, what are not the edges?
Maybe color change.
Color change, yes, could be. Wrong answers are acceptable.
Features of the cat, I mean.
Correct, features of the cat కావాలి, అదే కావాలి మనకి. But how do we get it? That is the expectation.
Drastic change of colors between background and the image.
That is a good theoretical answer, yes. There is difference kada. So దాన్నే మనం in computer vision we call them as filters. Okay, so there is one famous filter called Sobel filter. Okay, now before I dive into this, I just wanted to talk about, so when I was doing my masters, my professor, he's been into machine learning from 1980s. So he's always into computer vision. So he used to tell me, what about the kernel that I'm showing you, right? This one, ilaga, there are different filters. All of those filters are hand derived. So on a piece of paper, they used to create these filters, multiply and see what is the resultant image, how was it affecting. So many of these filters that you see are hand derived by scientists avvachu, math professionals avvachu, computer vision, machine learning engineers, whoever appatlo. So they used to do this. Now we don't have to do all of this, because a fully connected convolutional neural network ఏదైతే మీరు వాడుతున్నారో, it essentially extracts extracts these kind of filters from the image for its own understanding. So now Sobel filter edaithe undo, now what happens is it takes this image, multiplies the whole thing with the cat. Now what is happening is it's slowly getting rid of all the unnecessary information. First color egargottin, color egargottaka, then it, as Arpita rightly pointed out, it is taking about the differences that is happening. Once it gets the differences, that is where the matrix is getting multiplied and it is able to get to those edges, those different features of the cat. I hope I'll be able to pause. Oh, sorry. Okay, wait a second. Oops, sorry. Oh, okay. But anyways, so those kind of filters ఏవైతే ఉన్నాయో, that is what helps in getting these edges ఇక్కడ. Similarly, if you look at NLP, NLP lo if you look at it, there is similar thing that is happening. The model is able to learn different features only because of filters like these. Similarly, in the space of NLP, no, you might have heard about attention mechanism, right? I hope you guys have heard about attention mechanism. If you heard about it, just quick show of hands. Okay, so then how many of you heard about ChatGPT? Yeah, right. Now ChatGPT lo, when you ask a question, okay, why did Satvik had to ask this question, right? What is the emphasis? What do you think is the emphasis? Satvik asli question enduku adigadu is the question. So ఇప్పుడు నేను let's say for example, if I ask you, Tejas, why did Satvik ask that question in the first session? So what is your understanding of the question?
Maybe he's college student, so he's getting.
నేను ఇప్పుడు ఏదైతే క్వశ్చన్ అడిగానో, వాట్ ఈస్ యువర్ అండర్స్టాండింగ్ ఆఫ్ ద క్వశ్చన్ ఐ ఆస్క్డ్?
సాత్విక్ ఎందుకు అడిగాడు క్వశ్చన్?
కరెక్ట్. దాంట్లో నీకు ఏం అర్థమవుతుంది? వాట్ డు ఐ వాంట్ టు నో?
క్వశ్చన్ యొక్క మీనింగ్.
కరెక్ట్, యా. సో ఎసెన్షియలీ సాత్విక్ ఆ క్వశ్చన్ అడగడానికి కారణం ఏమిటి, రైట్? వై డిడ్ హీ వాంట్ టు నో ది ఆన్సర్ టు ఇట్? సో దట్ ఈస్ వన్ వే ఆఫ్ అండర్స్టాండింగ్. ఇంకో వే ఆఫ్ అండర్స్టాండింగ్ ఏంటి? వై డిడ్ సాత్విక్ ఆస్క్ దట్ క్వశ్చన్ ఇస్, okay, maybe I'm frustrated with why Satvik had to ask that question. Okay.
No, continue.
Okay. So there is different way of understanding kada. You've got like what is his emotion behind it. There are different ways of understanding. So all of this is possible because of the patterns or understanding that we get out of the matrix multiplication. Okay, now so okay, now we are able to do matrix multiplication. We've got all of those things. Now the big question is, how do we know that if something is right or wrong, right? How do we know if some learning is the right learning or wrong learning? So that takes us back to 1986. So there was a paper called Learning Representations by Backpropagating Errors. Okay, next I'll try to take things a little faster. In the country, I think I've blown past 20 minutes by 20 minutes. So I want to open it up for questions also. So this is the concept that was introduced back in 1986, which is basically backpropagation. Backpropagation is something that you've heard when you're learning about machine learning models, but what powers the backpropagation? Those are your partial differentiation. How many of you remember partial differentiation? Just show of hands is enough, right? So partial differentiation is very, very crucial component of backpropagation. Of course, there are a lot more things that enable backpropagation, but that is one of the crucial things. The other thing is a chain rule. How many of you remember the chain rule that you use? Right, f of g of x, when you're differentiating, you have to apply first g of x and then f of x. Our chain rule is not chain rule, and then of course linear algebra. Right, so all of these three, and of course there are many things, these three things enable back propagation. But then idanta okay, there's one main concept. I'll introduce that, but before that, just quick visualization. This is a simple neural network trying to learn a sine wave. So if you see, all of them are trying to fit a best line possible to learn the pattern of a sine wave. But if you see, one has already finished at 71 iterations, one is still learning, one's closer to finish here at, at 246, one is at 500 still going, 447, and one is at 537. So now I have a question. Why is that? It is the same data, it is the same network. Why is that in one model it is able to learn at 71st iteration while the other is at 537th iteration? This is because gradient descent. ఇది ఇంకొక math concept. So gradient descent is nothing but it enables you to get the model to best possible point where the error of prediction is low. So how is this visualized? Right, so let's say you start somewhere here. What you're doing is, okay, this is where the lowest possible error is possible. But in order to go from here to here, the important fundamental thing is you need to go down. How do you go down? You use mathematical concept again is differentiation. So our differentiation is so the reason I bring this up is, Manam, when we've done differentiation, when we've done all of these concepts are something that we just used for practice. But however, these things are what makes it simple. I mean, what makes it possible for the models to learn. Now I have a question. uh, I think I might have blew past some questions that you need to answer. Let's see. Okay, this one I'll finish. Okay, so I've started one question. So can you quickly answer that? Okay. So next question. Mm, yeah, this is what I want you to answer now. right? Of course, it's again math, right? So we are basically trying to go to the lowest possible point as possible. If this is that simple, why is that some took 537, some took 71? It is because the high dimensional space is not as simple as we looked, right? It's got different high points, different low points. So let's say ikkadiki vachindanu, but that is not the best possible error, lowest possible error that is that can be found here. Now, quick question: you know where it was? Which direction should it go to get to the lowest point? You know the starting point. In that screen lo చూపించాను. I've shown you the starting point. Now, where should it go? Left or right? Possibly left. ఇందాక చూసినట్టు. No. ఇప్పుడు అది right లో ఉంది. So high dimensional space you never really know where what exactly is present, which makes it difficult to understand. That is the reason. Again, mathematical when you look at it, there is different there are different concepts called learning rate. There is different steps, number of steps that it can take. Avanni, those all play into this. So all of those concepts, all of those mathematical concepts, matrices avvachu, partial differentiation avvachu, linear algebra avvachu, all of those things come into helping the machine learning models learn. Now, wait, so why is that I'm talking about all of these things is at the end of the day it is a black box. Machine learning is a black box, and you need vectors that help into your learning. Then you've got linear algebra that helps into your learning, model learning. Then there is partial differentiation that is helping into the black box. Now, all of these things are fitting into a black box without you actually knowing what has what influence. So Allah Juskunte, there are a lot of many other machine learning concepts that just come into this uh, the black box that you're trying to train the model in. So once you've got all of those math, then you've got your own ML model that does one task. Now, when you take the ML model out of the shelf, it is simple, it is easy, it is okay. But learning the mathematical perspectives will help open up, earn, apply, or research, or creative ways to explore machine learning problems or any problems in general. That is what I wanted to bring to this conversation. And last thing before I open it up is basically this. What happened now? How many of you have used magic eraser? Me phone lo something that you can erase. You've seen that, right? So ఇదేదైతే ఉందో this magic eraser, sorry, I think I've stopped share screen. So this is the recent project that I started working on, which is how do I use that in my own weather forecasting దాంట్లో. Now, this is made possible again because of something called as Fourier convolutional network. Okay. So Fourier transforms ఏదైతే ఉందో, Fourier transforms is one such signal. Of course, it could not in, I mean, not that any of you are from EC. There's one concept called Fourier transform in electronics branch. Our concept ఏదైతే ఉందో, they use that to build this model, which helps us in creating these మనం దీన్ని ఇన్ పెయింటింగ్ టాస్క్ అంటాం. సో ఇఫ్ ఎనీవన్ ఆఫ్ యూ is interested in how to use this, I'll give you a repo which you can use to fine tune a model or learn how to build your own task. For example, let's say you want to change a human face into a caricature. Tom and Jerry character పెడదాం అనుకున్నాను అనుకోండి. You can train a model that will help replace the faces with that of a cartoon character. I'll share this repo with Kartikeya or Tejas. They can share it with the others. So this is also possible because of extending one math concept into machine learning to solve a problem. Well, with that, I finish my session. And if you have any questions, feel free to ask. Sorry, I really took a lot of time. అసలు రియలైజ్ అవ్వాలి. కాదు, నువ్వు మ్యూట్లో ఉన్నావు.
Now we have some source కొన్ని notes ఉన్నాయి.
Hmm?
So that సో ఏంటంటే ఫస్ట్ అంటే మీరు ఎంఎల్లో జాయిన్ అన్నారు కదా, అంటే లైక్ లీడ్ ఎంఎల్ ఇంజనీర్ కదా. సో మీరు ఏం ఫేస్ చేశారు ఫస్ట్ బిగినర్గా, లైక్ యాజ్ బిగినర్గా స్టార్ట్ అయినప్పుడు మీరు ఏం ఫేస్ చేశారు, ఏ ప్రాబ్లమ్ అయితే ఫేస్ చేశారు?
డైరెక్షన్ ఫస్ట్ థింగ్. ఎందుకంటే I was learning stuff on my own, so that was one thing that I had the first initial. But the thing is, now things have changed. You've got YouTube, you've got a lot of people that talk about how to go ahead. The second is what is the roadmap for machine learning? That is one thing that I've initially struggled. And Srikanto, I mean, there were many times that we've started working on a roadmap for people. The thing is, I come from a applied standpoint, or let's say mathematical perspective. So for me, lot of the learning starts with math. So understand the intuitive concepts of math before going into machine learning. Not that that is the hard and fast route, but that is how I prescribe learning. So that's been one thing. The other thing is data. Okay, problem statement తీసుకొని, where is the data? What is the data that I'm looking for? Those are a few things probably initial గా ఉన్నప్పుడు.
స్టూడెంట్స్ నుంచి ఇంకో క్వశ్చన్ ఉంది.
Mhm.
సో యాజ్ ఎంఎల్గా అంటే మేము సపోజ్ మీ ఎంఎల్ రోడ్ మ్యాప్ తీసుకున్నారు అనుకుంటే, సో మీరు
ML?
అంటే మేము ఎంఎల్ ఇంజనీర్ అవుదాం అనుకుంటున్నాం ఫర్దర్గా
Mhm.
అనేది. సో ఎంఎల్ వైపు అనేది వెళ్దాం అనుకుంటున్నాం. సో మీరు ఏ రోడ్ మ్యాప్స్ ఏం ప్లాట్ఫామ్ వాడితే బెస్ట్ ఆప్షన్?
Kaggle. Kaggle is primary. Kaggle Hugging Face is another thing where you can use. The thing is, there are various ways in which you can learn. If you want to getting your hands dirty is important. So to get your hands dirty, you need to build stuff. You need to take a problem, build something. It doesn't matter. Use ChatGPT. Use any kind of LLMs that you have at your disposal. Use them to build a machine learning model. But the thing is, once you start building it, ask questions. Why did this work? Why do we need to do standardization? Why do we need to do normalization? Why do we need to do tokenization? Why is there a need to convert a categorical variable? Why is that I need a lot of data? Why is that this data needs to be in this format? Do it however you want, but once you do it, ask questions as to why it worked. Okay, why it did not work, it will always be clear. Why it worked, another clear gondal. Because if you are satisfied with, okay, I've got the best possible accuracy, and if you stop it at that, the thing is, you will never really understand what helped you in getting to that. So next time kotta problem vachinappudu, you will not really understand, okay, even though you take the same algorithm, put it into the new data set, it doesn't work. You need to really understand as to what made that algorithm work for that data. So that helps in learning. So Kaggle, Hugging Face, build stuff. Fail fast attitude on that. Okay, another question.
బిగినర్స్ గా ఏమేమి మిస్టేక్స్ చేస్తుంటారు ఎంఎల్ కావాలి ఎంఎల్ చేయాలి
ఏదమ్మా?
యాజ్ బిగినర్స్ గా బిగినర్స్ ఎక్కువగా ఏం మిస్టేక్స్ చేస్తుంటారు? సో ఇండస్ట్రీ లెవెల్స్ లో కానీ లేకపోతే సాఫ్ట్వేర్ లెవెల్స్ లో కానీ.
Fundamental steps. Data pre-processing చేయకపోవడం. One of the thing that happens is you don't clean up the data. So fundamentally in machine learning, the saying is garbage in, garbage out. If the data is bad, then the predictions are going to be bad.
ఇంకోటి ఏంటంటే అన్న లైక్ సాఫ్ట్వేర్ ఇండస్ట్రీ ఫ్రెషర్స్ ని ఏం ఎక్స్పెక్ట్ చేస్తుంది ఎంఎల్ స్టూడెంట్స్ గా?
చెప్పు.
యాజ్ ఎంఎల్ అంటే సాఫ్ట్వేర్ లో ఫ్రెషర్స్ నుంచి ఏం ఎక్స్పెక్ట్ చేస్తుంది ఎంఎల్ రోల్ ఒకవేళ అప్లై చేసుకుంటే?
See, fortunately or unfortunately, many of the companies in India, you are essentially doing a wrapper mostly because of the whole boom of LLMs. Majority of the companies focus on building RAG-based solutions, basic question answer kind of chatbots అవన్నీ. So ఆ బబుల్ ఒకసారి బ్రేక్ అయ్యాక probably they'll start looking at uh, forecasting models, sales forecasting అవ్వచ్చు, stock inventory forecasting అవ్వచ్చు. So it depends upon, so there is a, when you're looking at machine learning or roles in machine learning, one of the things that I learned here from my manager is pick a domain that you're interested in. Don't just get into any role as an ML engineer. If you have a chance, look at the domain that you want to get into. For example, నాకు computer vision ఇష్టం. I love computer vision. నాకు NLP కన్నా. So for me, if I'm looking at domains, so editing companies, like for example Photoshop, or people in that domain, or security domain, um, or weather forecasting domain. So pick a domain which which has your interest in its plan, and then look for opportunities there. So that keeps it more clearer, in the sense where your learning is in line with what expectations, your work is in line with your expectation, and at the end of the day you want to have fun. So Tejas a question అడిగాడు. For students who feel scared of math, what's the best way to start learning ML? So here there are two things. One is you can do a lot of machine learning without actually learning math. So in order to do that, what you need to do is fail fast strategy. Take a problem statement, use the data, build Kaggle models. And Kaggle, you have a lot of data that's available. So keep building models, training models, see what is happening, do that. That itself helps you learn a lot about math or math based. So there is a person called Abhishek Thakur, Kaggle. You can look at his notebooks. There are a lot of amazing ML engineers and there. So there is this step called EDA, exploratory data analysis. మీరు చేశారు ఇప్పటిదాకా, right? Exploratory data analysis ఏదైతే ఉందో, that is the most important stage. అంటే ఆ సామెత ఉంటుంది కదా, ఇఫ్ చెట్టు నరకాలంటే I'll spend most of my time sharpening the axe. So try to understand do as much as possible with the data that you've got, and then give it to model, then let it do its magic. So Andal, if you're scared of math, that is fine. A lot of people are not everyone can get into machine learning through the math thing. So for all of them, just keep building stuff. Kaggle or JND, pick up a use case. For example, if you want to learn about uh, retrieval based systems, question answer based systems, what you need to do is don't learn the theory of transformer. Rather, build stuff. Take a LLM, see how it is able to respond, what is happening, then break down the unit modules of an LLM. So Akansh, you will be able to learn. That is the fastest way or best way, in my opinion, you can learn machine learning. ఇంకేదైనా క్వశ్చన్ ఉందా? Okay, perfect. So should we call it then?
Okay, man. Thank you so much for the insightful and eye-opening session.
I have a question again. So sorry. What not to do when you start to learn? What not to do? Postpone. ఇవాళ అనుకుని ఓకే రేపటి నుంచి మొదలు పెడతాను యాటిట్యూడ్ వద్దు. సో ఇఫ్ యూ వాంట్ టు లర్న్, start immediately. The thing is, the important thing in life is taking that first step and then take another step, and you keep taking steps. Doesn't matter if you fail, if you learn, I mean, if you've done something wrong, if something doesn't work, you just keep doing. Again, fail fast strategy is the best way to learn anything. And the other motto is అదే ఉంటుంది ఏంటది, start, but anyway, start now than tomorrow. దానికి ఒక ముహూర్తాలు, దానికి ఒక ఇది, don't draft a big plan. If you want to do something, the best time is now. So hopefully there are no last minute questions, and I don't want to interrupt Karthikeya again. So okay.
And మీకు ఏమైనా డౌట్స్ ఉంటే మీకు డిస్కార్డ్ అని పోస్ట్ చేయొచ్చు. సో దట్ అన్న కూడా ఆల్రెడీ మన డిస్కార్డ్లో ఉన్నారు ఆల్రెడీ. అండ్ మీకు ఇంకా యూట్యూబ్లో లైవ్ కూడా మీకు పోస్ట్ చేస్తే అన్న కూడా అబ్జర్వ్ చేయగలరు. ఆ తర్వాత మోడరేషన్ కూడా మీరు మీట్ అయినా సరే మేము మీకు ఆ క్వశ్చన్ అనేది చేస్తున్నాం, ఓకేనా. అండ్ మీ హెల్ప్ అండ్ డిస్కషన్స్లో మీరు పోస్ట్ చేయండి. సో దట్ ఇంకా మీకు వాళ్ళు తెలిసిన ఇన్ఫర్మేషన్ అనేది పోస్ట్ చేస్తారు, ఓకేనా. And once again, big thanks to the Vishwanatha. Thank you for the Bible section. Someone want to participate or not? Jyoti want to talk now once again.
What changes when we take ML from classroom